Starting the first illustration, the position vector of the object of mass is 25 kg and 10 kg. So here basically two particles are given and the two particles are having different mass. M1 is equal to 25 kg and M2 is equal to 10 kg. Their position vectors are also given. R1 vector is equal to 4, 7, 5 meter and R2 vector is equal to 1, 3, 5 meter. And we have to obtain the vector representing the gravitational force on these two objects. So first of all, the force existing on particle 1 by particle 2, that is equal to G M1 M2 divided by R square into R12 cap. This relation we have seen in the Newton's law of gravitation theory. Here the vector R12 is defined by R2 vector minus R1 vector is equal to 135 minus 475, that is equal to minus 3 minus 4 0 meter. Don't forget to write down the unit. And so the magnitude of R12 is denoted by small r, that is equal to under root of minus 3 whole square, that is 9, plus minus 4 whole square, that is 16. So under root 16 plus 9, that is 25, which is equal to 5 meter. So magnitude is obtained. So it is easy to find out the unit vector R12 cap just dividing the vector by its magnitude is equal to minus 3 minus 4 0 divided by 5. So minus 3 by 5 is minus 0.6, minus 4 by 5 is minus 0.8 into the last coordinate is 0. So this is R12 cap. Substituting the values of this R12 magnitude and R12 cap in the equation of force, that is F12. Now the value of gravitational constant is provided 6.67 into 10 raised to minus 11. The product of two masses is M1 into M2 divided by R square. What is the value of R? It is 5. So 5 square is 25 and the unit vector is minus 0.6 minus 0.80. So here 25 had cancelled and so the force exerted on these two particles is given by 6.67 into 10 to power minus 10 because 1 is cancelled out into minus 0.6 minus 0.8 and 0. So this is the value of force on particle 1 by particle 2. And this unit vector you can also write in this form. Therefore, F12 vector is equal to 6.67 into 10 to power minus 10 into minus 0.6 is the vector or the component of x direction. So I am putting here I cap minus 0.8 and this is the component of y direction. So it is j cap and the unit I am putting as it is. So this is the value of force exerted on particle 1 by particle 2. Similarly, what will be the value of force on the particle 2 by particle 1? So this is minus 6.67 into 10 to power minus 10 minus 0.6 I cap minus point at j cap Newton. And this minus sign I can now substitute in this equation. So that is equal to 6.67 into 10 to power minus 10 0.6 I cap plus 0.8 j cap Newton. So F12 is equal to minus F21. So both values had been obtained. Illustration number 2. At each vertex of an equilateral triangle, a particle of mass m kg is placed. Now see here, we have taken an equilateral triangle and each point or each side we have put the mass m particle. So we have to find out the gravitational force acting on the mass m kg placed at the centroid of the triangle. So this is the centroid of the triangle at which capital M mass particle is placed, and the distance of the centroid from the vertex is 1 meter. Now, as this is an equilateral triangle, so the angle made from the centroid to the each side is of 30 degree because it is at center, and this angle, you can say angle ABC is equal to angle BCA is equal to angle CAB, all are of 60 degree. And now we know some angles. Angle XGC due to this centroid is 30 degree, and also angle X-GB is 30 degree again. So now the force on the particle at G due to the particle at A. So mainly we are finding out this value FGA vector is equal to, now gravitational constant is as it is, the particles of first which is having mass m and another is having capital M divided by the distance. Here the distance between particle G and particle at A is 1. So 1 square into the value of y, means here only the direction j cap comes. So this is the first result. Similarly for particle at B and particle at C, I can write down in this way: FGB vector is equal to GMM divided by 1 square into minus I cap cos 30 minus j cap sin 30. So that's why we have used this angle XCG and X-GB. And finally, for the particle at C, the force is FGC vector is equal to GMM divided by 1 square. And here see why I have taken the minus sign on both the way. Because here the negative x-axis and negative y-axis is coming. But here if you see in the fourth quadrant actually, positive x-axis and negative y-axis is coming. So there is a slight change in the unit vector. I cos 30 degree minus j cap sin 30 degree. But there is no change in the angle. So these are results 1, 2 and 3. Therefore, the resultant force on the particle at point G is given by capital F vector, which is actually the sum of the resultant sum of FGA plus FGB plus f g c vector, that is equal to gmm by 1 square into j cap plus gmm by 1 square into minus I cos 30 minus j cap sin 30 plus gmm divided by 1 square I cap cos 30 minus j cap sin 30 degree. And here these values are negligible, so they will be cancelled out, and the remaining one are this minus gmm divided by 1 square j cap sin 30, and here also minus gmm upon 1 square j cap sin 30 is there. So my result will be f is equal to, first term is as it is, minus 2 times gmm over r square. Here r, instead of r I am putting 1 square into j cap into sin 30 is equal to gmm over 1 square j cap minus 2 gmm over 1 square into j cap. The value of sin 30 is 1 by 2, so this 2 is cancelled out. So now gmm into j cap minus gmm into j cap. So the resultant force acting on this system or in the equilateral triangle from the vertex is 0. And now we will solve, or we will move to the next approach of gravitation, that is related to acceleration.